All right, moving on to our next example, we are going to talk about inscribed circles. We just did circumscribed circles where there was a triangle inside of a circle. Now we're going to do an inscribed circle, and we will talk about what that is. How can you construct a circle that intersects each side of a given triangle in exactly one point? So the circle that intersects each side of a triangle at exactly one point and has no points outside of the triangle is the inscribed circle of the triangle. So if you notice, the circle is inside of the triangle, so it is an inscribed circle. So that's a good way to remember that. There are no points outside of the circle. No points outside of the triangle. And the sides of the triangle must be equidistant from the center of the circle. So go ahead and write that in. Pause if you need to. So the side of the triangle is the same distance to the center of the circle. You can see that in the picture. All right, so if you had a different triangle, let's just sketch a triangle that looks like, I don't know, whatever we want it to look like, I guess. Maybe something like that. And we wanted to find the center of the inscribed circle. That's called the incenter. We would use angle bisectors of our vertices. So let's write that in here. The angle bisectors of a triangle intersect at a point that is equidistant from the sides of the triangle. So a rough sketch of what that would look like is if I were to go to each vertex on this triangle and sketch in. Now we can construct this with a compass and be very accurate. But if I were to sketch in the angle bisectors of each vertex, so I'm going to look at this vertex right here. I'm going to do a sketch of what I think looks like the angle bisector. Now I'm going to move on. So remember, angle bisector is cutting an angle in half. It's bisecting the angle. Now let's take a look at this angle right here. I'm going to do the same thing. And again, sketching it is not the most accurate way to do that, but I just want to show you how this works. So there's another angle bisector, and if I go to the last vertex right here, and I draw in an angle bisector of this angle, do you see how all three of those angle bisectors are going to meet at one point? That point is the incenter, and that will be the center of the inscribed circle.